I added the first cut of Kinematics to my Hexapod robot. It can walk and it can dance, and I even built a handy UI to control it. All design files and the software has been publicly released. In a previous video, I showed the hardware setup. I decided to use a Raspberry Pi Pico W for the microcontroller because it supports MicroPython as well as Wi-Fi and Bluetooth. Unfortunately, it only supports up to 16 servos, but this Hexapod has 18 servos. So I added a PCA 9685 controller. I have the GPIO pins controlling the servos on the left and the PCA 9685 controlling the servos on the right. Everything is powered from a single 2S LiPo battery pack that passes through a buck converter to provide a constant 5 volts. Using the Wi-Fi on the microcontroller, I was able to create a web-based UI by setting up a small web server. Using a web-based UI is very handy, as it can be accessed on almost any platform, including Windows, Mac, Linux, as well as mobile platforms such as Android and iPhone. Because this is all running on a microcontroller, it can't handle anything too flashy. Retrieving large images or files from the microcontroller would be quite slow. However, simple CSS styling and low-fidelity SVG graphics work quite well. Using a RESTful service similar to JSON RPC, I can communicate with the microcontroller by sending small packets containing short JSON messages to tell itself like what direction I want it to move, while keeping the processing overhead to a minimum. The first page I added to the UI is a simple status page. Here you can see the current status of the robot, including the current uptime. This is useful for determining how long your battery lasts and when it needs to be replaced. It also shows any warnings or errors encountered since the last boot. The full log can be read by plugging into a computer. This is mostly useful for debugging or if you want to add new features. The next page is the controller. It has two modes, user-controlled and scripted. For user-controlled mode, I added a simple directional pad to command the robot to move forward, backwards, right, left, as well as to rotate. On the right, I added a slider for controlling the speed of the walking gait. At the bottom, you have controls for setting the main body's position, including its default height and the direction that it leans. If you switch it to scripted mode, it will run through a pre-scripted action and it will start to dance. This is a great opportunity to see how the robot behaves without user intervention. And the last page that I added is the calibration page to make it easier to calibrate the servos during setup. Hobby servos are notoriously inaccurate. To get precise movements, each of the 18 servos have to be calibrated individually. You can set the min and max range for each servo to prevent them from burning out from overextension. You can also give each servo an offset from the 0 position to correct any misalignments during mounting. Setting up the software is rather easy. I've uploaded all the software to github.com, a link is in the description. Start by cloning the software repository to your computer. Only one file needs to be changed. Find config.py. It contains all the user-defined settings for the robot. The SSID and password fields need to be updated to your Wi-Fi connection. Once that is done, all the files need to be uploaded to the robot. For this, I like to use Thonny. It is a simple Python IDE with built-in support for uploading MicroPython scripts. With the microcontroller plugged in via USB, select the correct port from the pop-up menu by clicking on the Python version in the bottom right corner. Then select the files one at a time, right-click, and upload to the microcontroller. It works fairly well, though it is a little slow even with the speed cranked up to maximum. Right now, I have it stepping with one leg at a time to prioritize maintaining good balance. A different walking gait could speed it up. Switching to scripted mode works well. The dances may be basic, but it looks well executed. It is able to cycle through and repeat its scripted moves seamlessly. This gives me opportunities to develop more sophisticated dances and movements. However, I have noticed a few areas of improvement. When it tries to walk on hard, smooth surfaces, such as floor tile or my desk, I notice that the feet will slip. I may need to look into creating rubber feet to give it more grip. I also experimented with different walking gaits, including where it steps with 3 feet at the same time. It should only need 3 feet on the ground to stay balanced. However, I had trouble keeping the main body off the ground. It looks like the servos couldn't lift its weight. I think the servos may be underpowered, and I may have to look at adding a second buck converter to increase the available amperage. If you have any ideas of how I can improve this robot or what I should do with it next, please leave a comment down below. And be sure to give this video a like and subscribe for future project updates. Thanks for watching.